Thank you for choosing this video on Maldi Tof mass spectrometry. Maldi stands for matrix-assisted laser desorption ionization time of flight. I'm Professor Dr. Moina Mol from Dr. M. Kazi Institute of Chemistry, University of St. Jamshedpur. And this is my presentation. This picture here is a picture of how a Maldi Tof instrument looks like. Maldi Tof mass spectrometry is an adaptable or a multi-skill technique. Maldi stands for matrix-assisted laser desorption ionization. It detects and characterizes molecular mass of different mixtures of macromolecules, polymeric compounds, and biomolecules like proteins, peptides, and saccharides, etc. using laser desorption and ionization. This technique is also called soft ionization due to the fact that the compounds not being fragmented and ionizes whole during the analysis. Now let's see how the sample is prepared. Maldi sample target made of stainless steel. Now this is a stainless steel plate. On this plate there are several circles, and these circles are filled with the sample that is mixed with the pre-prepared sample, that is the combination of matrix and sample, and these are filled and then they are allowed to evaporate. And after the sample has been totally dried, the left crystalline material is used for analysis. Matrix and sample are dissolved in some miscible solvents and then mixed together. These are placed on a steel plate as shown in the picture and left for air drying. After being dried, the sample is placed inside the instrument for analysis. Matrix is an organic compound having aromatic rings. Examples are 3,5-dimethoxy-4-hydroxycinnamic acid, 2,5-dihydroxybenzoic acid, alpha-cyano-4-hydroxyl cinnamic acid. The ratio between matrix and sample is 10,000:1. Matrix facilitate ionization process by absorbing UV light. All matrix molecules have pi systems having conjugate rings. Now here in this picture, it simply tells us the ionization method that involves a laser striking a matrix of small organic molecules. These conjugated rings that we just told you in the previous lines, they absorb UV light and bang the analyte to gas phase. The laser energy absorbed by matrix molecules and will be accretionized from surface of sample, carrying the analyte molecules into the gas phase. The process involves two-phase method. Sample to be analyzed is fixed in a crystalline matrix. The initial ionization step involved bombarding a laser beam onto the matrix containing sample, leading to vaporization of the sample. The process progresses in a vacuum and are being ionized at the same time. The charged particles are accelerated by high voltage. The second step is the Tof mass spec phase. The particles will reach the detector in nanoseconds. This is called the linear mode. Now here in these two pictures, this figure number 1, it tells us the 3 different masses of particles hitting the detector with different velocities. Whereas in this next picture, second picture, particles lighter will reach detector fast. Molecules with greater mass will reach the detector later than the lighter ones. Calculations of the flight time enables to find masses of the ions. The spikes in the spectrum referred to as specific mass of the ion along with the time axis, starting from ionization moment. Then there is a reflector mode. The particles are redirected flying towards the second detector by expanding flight distance. The reflector also monitors the masses, and combo of these two leads to high resolution as compared to linear mode. So now this technique is also called soft ionization. due to the compounds not being fragmented and ionizes whole. Time of flight, mass spec accelerates ions in electric field with constant kinetic energy. As kinetic energy equals to half mv square, it will cause the smallest of the ions to travel the fastest. A mixture of three different macromolecules having masses 1 kilodalton, that is the smallest of having the mass to charge ratio, 2 kilodalton and 4 kilodaltons, that is having the largest of the mass to charge ratios. Now 1 kilodalton, as we know, equals to 1000 atomic mass units. So 1 kilodalton ion will be accelerated fastest with the velocity 54 kilometer per second. 2 kilodalton ion will be accelerated at 38 kilometers per second, and 4 kilodalton ion will accelerate at the speed of 27 kilometers per second under Tof conditions. Tof detector records the time taken by these ions to strike the detector. Keeping in view of standard 1.5 flight, the smallest ion hit the detector in 28 microseconds. 2 kilodalton will reach at about 39 microseconds, and the largest ion will reach at about 56 microseconds to the detector. Advantages of Maldi Tof mass spec. Number 1, soft ionization. Number 2, much better than electron impact ionization, that is also called harsh ionization, as being fragmented during the process. Number 3, no heating injection chamber is there. These are my references. Thank you.